Hello everyone, welcome back after exam one. So this section is now going to be section 2.5 and 2.6. Again, I'm combining two sections in one lecture. Uh, like I do every time, announcement again, the announcement of the homework first, the web assigned homework, because I see that some of you guys are just ignoring the homework. They are not doing the homework at all. Um, I don't know how you guys are going to pass this class if you're not doing the homework. It's going to be hard, trust me. So please, also, and some of you guys are not even watching this video, but just in case if you watch this video, then yeah, please do the homework, and maybe the first exam was, I think it was okay. I don't think I assigned any difficult problem in the first exam, but since this is going to be kind of like a take-home exam, right? You're doing everything from your home, so you are allowed to basically see your book, see the notes, but still you guys are not allowed to use the internet. But anyway, it's definitely easier than the regular in-class exam, right? So that's why other exam may not be this easy. All right. So that's why you need to watch my lecture videos, because I might be focusing uh, more on the idea I explain in the lecture videos from next exams, because some of the problem in the first exam, one or two problems were basically whatever I explained in the lecture videos. Um, so that's why definitely you need to watch the videos. But anyway, the homework 2.3, 2.4 was the lecture I gave you before the exam one. Okay, so this homework and 2.5 and 2.6, which is going to be today's lecture. These two homework is going to be coming Saturday. That's due coming Saturday, which is September 19 at 11:59 p.m. And in case if I assign any quiz in this video, so make sure you watch the whole video. And if I assign any quiz in this video, then it's definitely due tomorrow, because since this is a Monday lecture, so it's due tomorrow, Tuesday at 11:59 p.m., which is I think September 15. All right. Okay, let's start the section 2.5 and 2.6. First, let's start with the chain rule. Okay, so before I start talking about the chain rule, I expect that everyone watched the previous videos, basically this section 2.3 and 2.4. So if you haven't watched that video, please watch that. And then start watching this one, because I will be referring few things from that video. All right, so you need to watch that video. Just a quick review of what I talked in that video was basically a power rule. This is not the only thing I talked there, but this is one of the things I talked there. Power rule is basically if we have f of x is equals to x to the power n, where n is the number, then if I'm taking the derivative of this, then it will be this n times x to the power n minus 1, right? So in the chain rule, let's say if you have a composite function or something like this, f of x is equals to h of g of x, there is this function inside this function, right? So now if I'm taking the derivative of this kind of function, then using chain rule for this one, well, first we have h, right? So we need to take the derivative of this whole function. Okay, so this means derivative, right? Like I said, even here. So the derivative of whole thing, so derivative of h of g of x times, now after that, once you take the derivative of whole thing, and then after that, you need to take the derivative of this inside function as well. Okay, so let's do an example and explain you what does this mean. Okay, let's say if we have a function f of x is equals to x square plus 3 to the power, let's say 5. Okay, so now here, if there is just x square plus 3, then we can easily take the derivative of this using power rule here, right? You can just take the derivative of this x square, which is, when I bring this 2 down here, it will be 2 times x to the power 2 minus 1, which is just 1, plus the derivative of just number is 0, so I don't have to write that. But now I have this extra to the power 5 here. So here we need to use on this kind of problem or something similar to this, not exactly this, but something similar to this, we will be using chain rule. All right, so using chain rule, what we can do here is, first, I need to take the derivative of this whole thing, like I said here, take the derivative of this whole thing. So again, when you take the derivative of whole thing, you just need to treat this whole thing here inside as one variable so that we can use the power rule here. So first, when I take the derivative of whole thing, using something similar to the power rule, I can bring 5 down here. 5 times x to the power x square plus 3 to the power 5 minus 1. Okay, so here I'm taking the derivative of this whole thing, this process. Now times the derivative of inside function, right? Here I took the derivative of inside function. So the inside functions we have here is x squared plus 3. So then when I take the derivative of this inside, now take the derivative of x squared. So the derivative of x squared is 2 times x to the power 2 minus 1 plus the derivative of 3 is still just a number like a guy here, right? So then after this, this is equals to 5 times x squared plus 3 to the power 4 times 2x, and just multiply these two numbers, so it will be 10x times x squared plus 3 to the power 4. All right, so yeah, that's the derivative. All right, so make sure you write this derivative here again. Okay, so yeah, this is basically this is the idea of the chain rule. Okay, so I'll be doing few different kind of problems here. Let's do another one. Let's say f of x is equals to, let's take the derivative of square root of x to the power 3 plus 2x. So with these kind of functions, it's again similar to this, but what we have here is square root. Now what we can do with the square root is, I can change the square root to x to the power 3 plus 2x to the power 1/2, right? And then after this, now I can take the derivative. So if I'm asking to find the derivative, then after this, we take the derivative of this one again, take the derivative of this whole thing. So again, you can use the power rule for power rule for the whole thing. So bring this 1/2 down here, x to the power 3 plus 2x to the power 1/2 minus 1, right? So I'm using the power rule for the whole thing. Now after that, times multiply. Now take the derivative of this inside function. So first, when I take the derivative of x cubed, it will be 3x to the power 3 minus 1, right? Plus, okay, so I'm taking the derivative of this inside, right? So now plus, when you take the derivative of 2x, or basically we don't have, since 2 is multiplied with this x, I think I've explained about this in the last video. So 2 will stay there and just take the derivative of x. So when you take the derivative of x, it is 1. Again, I've explained this in the last video. Okay, so here I took the derivative of this whole thing. And then after that, here I took the derivative of inside function. Again, this is a chain rule. All right. Then after this, what we can do is 1 over 2 times x cubed plus 2x to the power 1/2 minus 1 is negative 1/2, right? And times 3x squared plus 2. Okay, now what we can do is, again, we can bring this, since we have this negative 1/2, so I can bring that to the denominator. So we still have this on the numerator, so 3x squared plus 2 in the numerator over this thing is in the denominator, right? 2. And then I can write that 1/2, positive 1/2. When I move this to the denominator, this negative will be positive, right? Now, again, I can change this to a square root, right? Because if I have 1/2, I can just write that. Just write the square root for this one. Right? And the 2 is basically here. Okay, so that's the final answer. Okay. Okay, so what about let's do this one. So the third example, let's say if we have y is equal to, we can write f of x or y, it doesn't matter, right? So sine of 1 plus sine of square root of 1 plus x. Okay, now when we're taking the derivative of this one, or y prime, or we can even write dy over dx, right? It's the same thing. Since we have x here, so I'm taking the derivative in terms of x, or we can simply write y prime. Okay, now again, using the chain rule, first I have to find the derivative of this whole thing, right? So that means I need to take the derivative of sine. So if y is equals to sine x, then y prime is, when you take the derivative of sine, it's cosine x. Okay, again, I have talked about this in the last video. That's why I keep saying that if you haven't watched the last video, section 2.3 and 2.4, then please watch that one first and then start watching this video, because that video is kind of like a prerequisite video to watch this video. If you don't watch that video, then probably this video won't make sense at some point. Okay, so you have to watch that. Anyway, when I take the derivative, okay, like I said, when I take the derivative of sine of something, it's cosine of that, or basically when I take the sine of x, it's cosine of x. So here, sine of this whole thing is cosine of that whole thing. Right? And then what? And then now take the derivative of this inside part, right? So let's, before I do that, let's just, okay, inside part is this whole thing, right? Square root of 1 plus x squared. Or like I said in the last problem, I can even write this as x squared to the power 1/2, right? 1 plus x squared to the power 1/2. So that means basically I need to find the derivative of this whole thing, or derivative of this whole thing. So when I take the derivative of whole thing, again, this is going to be 1/2 times 1 plus x squared to the power 1/2 minus 1, right? So I took the derivative of this one, the function that is inside this sine function. Okay, Now again, there is another function here inside this, right? And again, times when I take the derivative of now this inside part 1 plus x squared, then if I take the derivative of 1, it's 0. When I take the derivative of x squared, it's 2x. Okay, again, so that's why this is called chain rule. So there is a chain of finding the derivative. So here I found the derivative of this whole thing. Okay. And then after that, here I found the derivative of from here to here, I found the derivative of this part. Okay. And then after that, here I found the derivative of, let's write in black. So the derivative, again, the inside of this square root, which is this 1 plus x squared. Okay. Now, let's see if we can cancel something here. So it looks like this 2 on the bottom and this 2 on the numerator. We can cancel that, right? So then after that, we get, okay, so 1 over 1/2 minus 1, basically it's something similar. So 1/2 minus 1, if I move to the denominator, yeah, I will get square root on the denominator, right? So on the top, cosine of square root of 1 plus x squared. Still have this x, so let's just write that x here. And on the bottom, when I move this to the bottom, it will be the square root of 1 plus x squared. Right, so this is y prime, or dy over dx. Okay. Similarly, let's say you might even see something like this: y is equal to sine square x times cosine x. Okay, so here on this one, we should use two things. We should use chain rule, whatever we're doing right now, plus we should use product rule as well. All right, so the product rule, again, this was, I explained this in the last video. So that's why I keep saying, please watch the last video. So when we have a two function of something like this, and if these two functions are multiplied to each other, then to find the derivative of this one, then take the derivative of just one function times another function plus, now this function will be the same, and take the derivative of another function. Right, so again, I have also explained about this in the last video. So so we have two videos, right? Sorry, I'm sorry, we have two functions, right? So again, to take the derivative of this one, first take the derivative of sine square x. Right, so if we have two functions, we just take the derivative of one function. So when I take the derivative of this whole thing, sine square x, then I have to take the derivative of whole thing, right? So 2 will come down, sine x to the power 2 minus 1, okay? Or basically, we could even write this sine square of x like this, right? So this way you could see. So 2 come down here, and sine x to the power 2 minus 1. Okay, so that's, I'm taking the derivative of this part, right? And again, take the derivative of this inside function. So when I take the derivative of sine x, it's cosine x. Okay, so that means I found this part times g of x, or times another function. So another function is still cosine x. You have still cosine x here, so cosine x plus. Now after that, I found the derivative of this one here. So this red part, the derivative of the red part is this. Okay, plus. Now, this first, this function will stay the same. So which will be sine, or I can simply write it like this, right? Sine squared x times the derivative of now cosine is the derivative. The derivative of sine is cosine, but the derivative of cosine is negative sine x. Okay. Now, okay, so now we're almost done. So 2 to the power sine to the power sine x to the power 2 minus 1 is just sine x. Cosine times cosine is cosine square x. There is a minus since you're multiplying these two, so minus is going to come here. And then sine squared times sine x is sine cube x. And there you go. So this is the derivative. Okay, so yeah, so here I used two things. I used the product rule as well, right? This is product rule. And also I used the chain rule here. Okay. Okay, so again, the homework, you might see something like this, or basically for the wave assigned homework. Okay, so here, the idea is basically using the chain rule first. So I did a few examples here. Okay, now let's go to the next topic. So this one we used chain rule. Now another topic we have is implicit. Differentiation, or if differentiation means basically a derivative. All right, so implicit differentiation, here the technique is, let's say again, let's start with the example on this one. Let's say now x squared plus y squared is equals to 25. It's given. Now we need to find y prime, or we could even write dy over dx, right? So that means we are finding the derivative y in terms of x, or basically we're finding the derivative of y in terms of x, right? And we have this function where we have y squared. So far we were doing the example where there is just y without any power on y, and something like this is given, and we are finding the derivative of y, right? Or derivative of just, or simply we can write like this, so which is basically just 2x, right? Using the power rule. But now what we're going to do with y squared. So here the technique we're going to use is implicit differentiation. Okay, so using this technique, what we're going to do is, so now with x variables, since we are taking the derivative in terms of x, so when we have x variable, we just use the power rule, just like I did here. So for this one, x squared is just 2x, right? 2x plus, what about the derivative of y squared? So now since we are taking the derivative of y in terms of x, so the y could be something. So here, so for y variable, I have to take the derivative of this whole thing, like we did in the chain rule. So take the derivative of this whole thing, which is 2 times y to the power 2 minus 1. And then take the derivative of this inside function, which we have just y. So when you take the derivative of y, this is, we can write it something like this, right? Derivative of y is y prime is equals to, now take the derivative of this 25. So when you take the derivative of a number, it's a 0, right? Okay, so since we're trying to find y prime, so we found, well, we got the y prime terms here. So now we can find this. So from here, it's 2x, 2 to the sorry, 2 times y to the power 2 minus 1 is just y times y prime. So now here we can just subtract 2x on both sides. So that means this will go to the other side. So this will be negative 2x on the other side. And since we are trying to isolate y prime, or basically since we are just trying to make y prime on one side and everything else on the other side, right? So now just divide 2y on both sides. So I get y prime is equals to negative 2x over positive 2y. All right, so this is how you can find y prime or dy over dx. Okay, but what about instead of finding dy over dx, what about if I ask you to find dx over dy? Okay, so if I'm finding y, or the derivative of y in terms of x, I just take the derivative of x variable, something like this, right? Now, when I'm finding the derivative of x in terms of y, then in this case, or I could even write it like this, x prime. Then now take the derivative of this whole thing, which is 2x times x prime. Right, or we are finding x prime, right? So take the derivative of this whole thing, so which is 2x, and also we need to take the derivative of x, which is inside this function, since we're trying to find the x prime, right? Plus, now for this y variable, just take the derivative of y squared, which is just 2y, is equals to 0. Okay, you see the difference? So here, when you're taking the derivative in terms of x, then we find y prime. When you're taking the derivative of x in terms of y, then we get x prime terms. Okay. Now after this, just like we did here, move this to other side, 2x x prime minus 2y, then divide 2x on both sides, so x prime is negative 2y over 2x. All right, so be careful about this. Right, so these two are different things. So yeah, so here it will be just the change of variables. Okay, so be careful about this. So okay, so this kind of technique is called implicit differentiation. Okay. Let's do another one. X cube plus y cube is equals to 6xy. Let's just say xy. Okay, so here let's find y prime. Normally I'll be asking you to find y prime. I won't ask. Well, I'm not going to say I am not going to ask. I might ask this this x prime, but yeah, the technique is same thing. But I'm explaining you this just to show you the difference. What does the y prime means, or what does the x prime means? Okay, so just be careful about this. I might ask you this in the exam as well. But normally, like I'm saying, normally you will see y prime. Okay, so we're finding the y prime. So okay, from left hand side, since you're finding the y prime, so for x variables, we'll just take the derivative of this, so which will give 3x to the power 3 minus 1 is just 2, right? Now, since we're finding the y prime, so when we have a y variable, we need to take the derivative of this whole thing first, which is 3y square, or 3y to the power 3 minus 1 is y square, right? Times, then take the derivative of this inside, which is y, which is basically y prime, is equals to, now on this side, on right hand side, we have x and y. So here we need to use product rule. Okay, So using the product rule, I have to take the derivative of one function. So let's just take the derivative of this x. So when I take the derivative of x, it's just 1 times the same function plus, now just write x and take the derivative of y. So since I have just y here, it will be just directly y prime. Okay, clear? Now since we are finding y prime, so I have y prime terms here and here, right? So that means I need to combine these two. Okay, so then let's just move this first. Let's just move this to other side, this to other side, and also let's just move this to here, this side, right? So when I move this to other side, it will be y minus 3x squared. And when I bring this to this side, it will be 3y squared times y prime. So this will be minus x times y prime, right? And now from these two, I can factor out y prime. Right? And then on the right hand side, it's the same thing. So y times this whole thing. So now to get just y prime on one side, just divide this whole thing on both sides. So that means this is gone. So y prime is equals to this whole thing. So let's just write that down here. Right? So yeah, that's how you find the y prime. Okay, so here I used the implicit differentiation, and also on this side I used the product rule. Or you might see where you should use the chain rule as well. Okay, but anyway, once you understand the idea of the technique, and once you do few problems, then you will understand it. It's all about getting practice with these kind of problems. When I'm explaining, basically in math, when I'm explaining, it makes sense. Most of the time it makes sense. You'll see, oh, I get it. But once you start doing the problem by yourself, you get confused easily. So that's why more you get practice on math, then you understand more. Okay, so that's the basic idea of understanding math. You should do more problems. Okay, that's how you be successful in math. That's the simple formula to do well in math. Get more practice with problems. Okay. Okay, now let me assign you a quiz. Okay, so use the same implicit differentiation. Let me just write DFF, implicit differentiation. And the problem is y to the power 4, sorry, x to the power 4 plus y to the power 4 is equals to 16. And what is y prime? So find this. So this is a quiz problem. Okay, so if this is a quiz problem, then this is due tomorrow. Since this is a Monday lecture, so this is going to be due tomorrow, Tuesday at 11:59 p.m. like I explained in the beginning of the video. All right. Yeah, keep watching the whole video. I might assign more problems as well. Okay. Now let me do the problem. So here I will be basically, I have done the problem something similar already. I think on section 2.2. So here we need to find the slope and equation of the tangent line to the curve x squared plus 2xy plus 4y squared is equals to 12 at 2, 1. Okay, so I have done something similar problem. It's just that here the equation was different. Well, now in this one, we need to use the implicit differentiation. The one I explained on section 2.1, 2.2, probably in that one it was different kind of equation. But anyway, here first, so as we know that the slope is basically if we find the derivative, then if I can find the derivative at this point, then I can say it's the slope of the tangent line at that point, right? So first let's find the derivative, or first let's find the y prime. Okay, so to find the y prime, again, I need to use the implicit differentiation, right? So using implicit differentiation, or to find y prime for x variable, you just take the derivative of that. So 2x plus, now here we have 2x times y. Now here we need to use the product rule. So first let's just take the derivative of 2x, which will basically, it's just 2, right? 2, and the second equation, which is y, will stay there. And then after that, this 2x will stay there, and take the derivative of y, which is y prime, right? And again, here 4 times y squared. So now we have a y variable. So when you're taking the derivative y variable, well, 4 will stay there. When you're taking the derivative y variable, first you take the derivative of this whole thing, y squared, which will be 2y to the power 2 minus 1, which is just 1 on the power, times the derivative of this inside, which is y prime, is equals to the derivative for number is 0. Okay. Now, now what we do here? So basically now here, since we are finding, we're trying to find y prime, so let's just move this thing to other side. Plus 8y times y prime is equals to, when I move this to other side, it will be negative 2x, negative 2y, right? And then from here, I can factor out this y prime. So 2x plus 8y is equals to negative 2x, negative 2y. And after this, just divide divide this whole thing on both sides. So y prime is negative 2x, negative 2y over 2x plus 8y. Or simply we can even say, when we, since 2, there is 2 here, I can factor out 2. So there will be negative x, negative y inside the parentheses. Similarly, there is 2 here, 8 here, so I can factor out 2. So 8 plus 4y, right? The reason I'm doing this is I can basically just cancel 2. So this is y prime, right? So this is, let me write this here again. So this is y. Okay, so now since we are trying to find the slope and the equation, right? So once you find the y prime, well, we are trying to find the slope at this point. So what I can say is at that point, at this point, 2, 1, at this point, the actual value of y prime is, since we found the y prime equation is this, so minus x is going to be 2, minus y is 1 over x is 2 plus y is 1. So 4 times 1 is just 4. So negative 3 on the top, 6 on the bottom. So negative 3 over 6, which is also negative 1/2. Right? So so this means what does this mean? So we found the value of y prime at this point. So this means this is the slope. This is also slope of the tangent line. Okay. So please understand this idea. So the value of the derivative, at certain point means the slope of the tangent line at this point. All right, so understand this idea. I might ask something similar to this concept in the exam. All right, so be clear about this concept. And again, after that, since we are trying to find the equation, all right, so since we know the slope, so if you go to, so we know the slope, which is negative 1/2. We have a point, which is 2, 1, right? We know the slope, we have a point. Then how can we find the equation? Oops. How can we find the equation? So this is from algebra. So we know this equation, y minus y1 is equals to m times x minus x1. Okay, so this m is the slope. Y1, well, for this point, I can assume this as x1, y1. So then y minus y1 is 1 is equals to negative 1/2 times x minus x1 is 2. Okay, then after this, y minus y1 is equals to, distribute this, so negative x over 2, negative times negative, that's positive. So negative 1/2 times 2 is, this is gone, so it's just positive 1, right? And then move this to other side, this negative will be positive, so y is equals to negative x over 2 plus 2. So this is the equation. Okay, so yeah, this is how you find the equation, and this is how you find the slope. Okay, so that's it for this video. And if you watched the whole video, then probably you noticed whether I assigned any quiz or not. And if I assign any quiz in this video, then it is due tomorrow, which is September 15. I've explained again at the beginning of this video. Yeah, please submit by tomorrow if I assign any quiz, and also make sure you do your web assigned homework on time. All right, see you in next video. Thank you.